Hiya guys, and welcome back to Aid's Workshop. So I've had a look at the footage that I was going to include in this video, and on a few occasions I've lost a bit of footage or didn't turn the camera on. All my fault, all this stuff. So it's going to be a little bit disjointed. We're going to go ahead and make the pulley that's going to go on the end of the spindle, the pulley that's going on the motor. I've now got the belt in stock, and I think we'll look at blocking up and making a start on the riser block that's going to fit the tool post on the compound. On the cross slide. So as I've done with my Walco lathe, I'm going to have a riser block that replaces the compound slide for general use. But I do want to make it so that I can just whip the riser block off, put the compound back on using the same tool post, and be able to have that versatility so that I can have the compound. So that said, I'm going to have to make this riser block the same thickness. There's all sorts of things to take into consideration. Now, I've been thinking about tool posts, and I think I'll use the 00 size. I have seen them in Arc Euro Trade, so I think I'll probably end up buying one from there, and it's going to be very similar to the one I modified for a chap a few weeks ago, or in fact probably the same one. So that's where I'm going with that, but I haven't got it in yet to measure it up, so I can't complete the riser block. Anyway, that said, I'll show you where we are. So yeah, we're making the pulley that goes on the motor. I have already made the one that goes on the spindle. I'll show you that momentarily. I've decided to go for a bit of a differential between the two gears. Of about 10mm difference. So I'm just roughing this out. I don't know what diameter that is at present. Let's have a quick squint. I think I'm going to drop that down to 30mm. Let me just check the spindle on the motor. Spindle's 14, so 30 should be fine for the bit that fits over. So what did I say it was? 38 it is at present. It's just set a 0. So 4mm aside to come off. Let's do 4 1mm passes, shall we? Just taking 2mm off at a time. That's a 1mm cut. We go a bit faster with the feed. There. This particular aluminium is very soft indeed. Let's take 2mm off with this pass. See if we can yeah, that's taking 4mm off in one cut. Yeah, it's very soft. It's gluey, this stuff. So it should be 1mm left to come off. So let's take, I don't know, 1.4 off. 1mm aside left. I'm taking it off. So it's 0.3 aside to come off after this. I think this 30 is not important. It's just a number I've come up with. But I like to work in round numbers where possible. So that's that 4mm we're referring to. Speed that feed up a touch. Okay. So let's drop that down to 30mm. Ish. Get the calipers on it in a sec, see where we got to. I suspect just under. So when I machine the teeth, shall we call them, I will machine the OD at the same time in the same setup. So I'm going to be turning this around. So I'm just going to face that shoulder. Get something true in there. That's it. So let's see how we did. 29.7. That's absolutely fine. So let's just put a couple of brake edges on there. I've had to put the reverse jaws in to hold it. Holding it in the conventional manner, it won't quite hold in this chuck. A little brake edge there. I'll do the same there just for fun, just so we're not leaving something sharp on there. Okay, let's turn that feed off. So that can come out the chuck now, and I'll put the other set of jaws up. So that's roughed out just a shoulder on there, and I'll be able to hold it now the other way round. So I shall do that next. So I want this larger piece here that's stuck out the chuck to be 20 mil, and I did the shoulder on the back at approximately 20 mil. So let's just get a rough clean up on there, see where we are. So that would be 21.5. Okay, I'll just touch on there again. Set 0. 1.5 set 0. Okay, so 0 in X is my finished size. So I'm just going to rough this down to thickness, and we'll take a scratch over the OD. The bore is 14 mil, which is weird. I'll have to double check that. I just put a calipers on it, so I may have to bore that out. I know I haven't got a 14 mil reamer. I've got a 16, 17, I got a 15 I think, but I know I haven't got a 14 mil. Ooh, we're getting horrible rappy stuff going on. Let's get rid of that. Okay, pull that swap back out the way. Alright then. It's one of the handy things about having a large or extended bed behind the mill here. There's room for a lot more swap, and you can push it back out the way a lot easier. Not that it stops it wrapping round when you got this horrible stringy stuff, but well, what can you do? Okay, so we got 0.5 to come off. So, diameter on this pulley. I'll bring the one in that I've done. Oops, nearly dropped it. So here's the one I've done. And, well, it shows it's clearing out a bit. But the grooves are in it for the belt. Let me just show the belt. Here's the belt with its grooves. And that sits on the pulley. An absolute treat. So, we're going to go for the same method again, and I'll show you my method this time. But yeah, it's going to look like this, obviously, very similar, but with a smaller bore in it. So the other pulley worked out about 56 mil in diameter. I think I'm going to reduce this one and have a 46 mil. So yeah, where are we? Let's just get a touch. It's about 50 mil now. So going to be 2 mil aside off it roughly. That's a mil aside. Let's see how that looks for a cut. Yeah, not bad. Again, the diameter doesn't matter. I'm not aiming for a specific ratio. Just 10 mil smaller, you know, ish. Oh, straight at me. So I'm using an Allen key in my hand. I'm not grabbing over this wall. Just pulling back what I have got out of the way. And I'll have a clear up of that swarf around the chuck after this cut. Yeah, yuck. Oh, I should get my pliers out really. Yeah, I think we'll stop this shot. I'm going to have to go and get my pliers. Oh, have I got it? I've put my pliers away in the drawer, I believe. Yeah, can't see them. No, tough little swine. Oh, I'll keep the camera rolling just to show you the sort of hassle you get with the rappy swarf. It's horrible. Yeah, this aluminium, it's just extruded aluminium bar. It's cheap as chips, and I buy it cheap. Let's have that out of the way. Okay. Right, we got it out. So yeah, and it does string up, and it's something horrible stuff. Let's just take a couple of small cuts here. Horrible stuff, but it machines nicely once you get rid of the stringy bits. So yeah, with a small cut like that, the swarf's a bit more friendly. That was a 0.2 cut. We'll do another one of those. We should be somewhere near a 46 mil now. A little bit of WD-40. Not that it matters. We're going to put a form on top of there. Okay, let's see what diameter that is. Come on, out you come. I'm clinging on there again. So yeah, I'm aiming for a 46-ish. 46.4. Let's take another 0.2 cut then. Just pull the swarf out the way. Okay. That should be it. So when I finish this cut, I'm going to go over to the motor and actually put a mic on the shaft, see what it is, and then we'll look at what bore we got to put in here. Now we're going to have to cut some keyways. Well, we haven't got to. We could just screw them on, but yeah, I think I will cut some keyways. So that's going to be a bit of fun. As we haven't got broaches or keyway cutters or anything like that. So yeah, we'll have to have a quick think about that one. We might have to grind something up, and 46.1. We'll live with that. So next step, mic the shaft up, see what size bore we got to put through for it to fit on the motor. So I've centre drilled it, and I'm going to whack a 10 mil drill through it. Probably a 12 then, or maybe a ½ inch. See if I can dig out a ½ inch drill. And then we're going to have to bore it out, because it is indeed 14 mil as we suspected. And as I suspected, I haven't got a 14 mil reamer. I got a 12 mil, I got a ½ inch. I haven't got a 13. I've got a 15, I've got a 16, and I've got a 17 mil reamer. But no 14, which is a shame, because that would have made it quick and simple. So yeah, we'll have to do it the old-fashioned way with a boring bar. This aluminium really is claggy stuff. Keep a bit of WD on it, stop it welding up. Give a bit of speed might help, yeah, it's bringing it out the flukes a bit more. Yeah, it really is sticking in the bore here. I'm getting somewhere near now. Just drilling a hole, guys, so I'll bring you back when I'm done with the drilling and then we'll get the boring bar out. It's tricky to show what I'm doing here. The pitch of the grooves in the pulley is 2.4 mil, and I've got a V-cut tool set up 60 degrees. Is it? Yes, I believe it is. And what I'm doing is feeding in 1.1 millimeters. So I'll just do this one. I will bring you around the other side in a minute. It just chatters as they go beyond 1 mil. Typical. So yeah, so I index along now. So I'm on 7.2. Plus 2.4 is 9.6. So I'll move along to 9.6. There. I'll bring you around this side. Okay, so I did bring the camera down, guys, and I do apologise. I forgot to turn it on. I was concentrating on what I was doing more than anything else. But you get the general idea. I was feeding in 1.1 mil. I found that out to be the perfect size on the first one I did, and indexing along 2.4. And I basically gauged that with the calipers. Can I get that over there? So I've got a bit of deburring to do now on the outer edges with a cut sort of half run of tooth. I must get my pliers over here. Let's bring the tool out that way. So I'll bring you around and show you the finished result. Can I get that swarf out? Come on. Last couple of bits. So I'll grab you off your stand there, guys. So we're going to do a bit of a move around here. Oh. That's ignore that noise, guys. It's a little clock I've got here, and the battery's gone, and every time I bump it, it comes back to life, thinks it's New Year's Eve. Yeah, the reflection's a bit weird on here. See if I can find a position. There we are, you can get it. That's better. So yeah, series of grooves for the belt are running. And with this one, it's a lot wider than the belt, so it gives me options as to different positions for the belt, which is handy. So should I have an alignment issue between top and bottom, even though I've got adjustability built in, I've just built some more in. So I've made up a little tool holder, and basically a piece of steel, grub screw in the end, cross drilled, and there's a little, well, it's a snapped off centre drill, an old centre drill, and I ground it into a form of, well, if you think of it as a parting shape tool, a grooving tool, sort of shaper style tool. So it's got a relief angle clearance top and bottom. It's got a cutting face on the forward and then a relief angle on the back here. It's difficult for me to show it. So there's my pulley, and what I'm doing is putting a cut on. I've locked the spindle in the lathe, don't ask how, but I have. And basically the tool then enters into the pulley, and if I wind the tool forward, you may see at the back, you'll see the tool coming through, and that's it, the tool passes through. So back off again, and you'll see the little chip there on the front. So if I just get that chip out of the way, gosh, this doesn't want to show, guys. Yeah, you can see there on the left hand side the keyway starting to form. Now it's got about 0.4, 0.5 to go yet, so I'll put you on the holder rather than freehand as I am now, and we'll do the rest of it. So I just give it a spray every few cuts with a bit of WD-40 just to help with a cut. Let's just put a cut on, there we are, and feed it through. So I put about a thou cut on every time, and I run it through just 3 or 4 times. There we go. So basically using the machine like a shaper. I'll have a measure after this cut. So probably taken me, well, it took me longer to make the tool than anything else, but probably taken me 10 or 15 minutes to machine this out, or hand shape this out. So I'm looking for 29.4 mil. 29.17, let me just check my dimension. Yeah, another 0.2. So set my DR out to 0 and just wind out 0.2. Cut's a bit heavy, I'm taking about 0.1 a pass now. Okay. Okay, so that's 0.2. Have a bit of WD. And when the deflection's gone, basically you're getting a more swarf coming out, and well, you can feel it. I'm just gonna go for a while on this last cut. Okay, can't feel anything there now. So 29.4. 29.35. Okay. I don't mind if it's a little bit over. I've just measured across the shaft with a key in it. So I don't mind if it's 29.45 across here. The key is 4 mil wide in the shaft that this is fitting on, and I've ground my tool to 4 mil wide. Well, if anything, a hair over, but yeah, 29.45 I'm looking for here. 29.44. Okay. So if I just try the key. Oh, that fits. I think what I need to do now, before I strip this down or break it down, It's just try the shaft in there. Can I get in? Not with that tool there. Let's just set a 0. Bring that tool out of the way. Right, okay. So obviously this is the wrong way round as it stands, and it's not stupidly tight to fit in here. Come on, back you come. Okay. Well, the shaft fits in. Let's try it with a key in place. So there's the little key in the end. Let's line it up. Well, it fits. It's snug, but it fits. Okay. Okay. I think we'll call that done. Okay, so there's the finished result. There's my keyway in the pulley. A little bit of deburring down the top edges there. So that's it. And it's right through the part, 40mm long. I'm pleased with how that worked out. I have done this before, many moons ago. But yeah, I mean, especially in aluminium, it's quite forgiving. But yeah, happy days. Just masked off my headstock all around everything that doesn't need paint, and giving it a coat of grey primer. I'm expecting my paint to come in tomorrow to paint it, and I think what I'm going to do going forward is I'm going to assemble the headstock with the bearings and everything, get that all put together, and then I can work out a bit more goings on with the pulleys and spacers and things like that. So yeah, that's got its primer. So I fitted the lower bearing onto the main spindle. Now I did go all around this spindle, polished up with Scotch-Brite, took out any little dinks and what have you that were on it, cleaned it all up properly before I installed this. And basically I put the spindle in the freezer, and basically I left the bearing out in the sun. I didn't want to put it in the oven, but I put it out in the sun, and it was fairly hot. You know, it was in direct sunlight, out the wind, and yeah, I could pick it up. Perhaps it was, I don't know, 30-40 degrees, something like that, C. And obviously the shaft was down -10, something like that. Basically the bearing then, just with the slightest of taps, dropped straight down to the bottom and locked in place there. Of course, when the temperature's all settled out, it won't go in anywhere then. So yeah, I did have to put the keep plate on with its oil seal first, or I wouldn't be able to get the oil seal on over the bearing. I could have just put the oil seal on, the plate will go over the bearing. But yeah, that's where I am on the spindle assembly. I've got that far. So as you saw earlier, I did put a coat of primer on the headstock. After it was primed, I fitted the two inner races, or outer races I should say, which are in the headstock, one both ends, and in fact that's now got its second coat of Walko green. I bought a tin of that. Let me show you the tin. Yeah, so there's a tin of paints, Paragon enamel paints. Now I bought this online. Walko machine green gloss. Yeah, it's spot on. So happy days with that. I've seen other YouTubers do sign writing and what have you using these Paragon paints, and first impression, it's excellent. So there's the pulley in place on the motor. This one I decided just to hold it on in the keyway with two M5 grub screws, and it does lock it solid. It was a good fit on the shaft. I wasn't going to go down the route of doing a keyway in this one, as you saw me do on the other pulley, but I've just put two big grub screws down into the keyway. I think that should lock it solid. So that's the cross slide off the mini lathe, and I just blocked up off camera this block of cast iron. I believe I bought this from College Metals. Yeah, it wasn't silly money. So block of cast iron, its raw size was, I don't know what it was, It was about 72 mil by 72 mil, something like that. And it was, I asked for 50 mil thick. Okay, so that said, I want this to fit on top of there, basically like that. Now it's oversized at the moment, as you can see. So I've just mic'd up a plate here, 65.07, and this block at the moment is, yeah, it's about, ooh, I'll get it in a minute, 70.75, 70.8. So, yeah, in this dimension, I'm going to put this in the vise this way up, and I need to reduce 5 mil off the top of there, so I'll get on and machine that away. So 2 mil at a pass, seems to be able to cope with that. I think I might do 2.5 on the next one, and that'll leave me 0.5 mil. I just squared up the two edges which weren't quite square in this orientation. Okay, we got them now. So yeah, the original dimension I hit, which was 65.0507, and that's 65.03. So yeah, more than happy with that. That's, you know, that's where I want to be, or thereabouts. So deburr this now, and we need to look at the thickness. I just cleaned the muck off the underside and top side. I haven't looked at this at all. .73, so I'll write that down. So 39.73, we'll call it 40 mil nominal. Yeah, 51.1. So I'm going to take 11 mil off it, take it out, give it a measure, see where we are. But yeah, it seems horrible to cut 11 mil off there, but yeah, such is life. I ordered a piece of steel too big, but at least it wasn't too small. So just taking the last millimetre off, and this should bring it to size. So we've got the block then pretty much on dimension in its cube form, shall we call it. It's going to be a bit more machining and drilling and chamfers and all sorts to go on this yet going forward. But yeah, we'll get there. I do need the tool post before I can actually sort of make some decisions on sizes and what have you. Come on, off the end. Back the other way. Well, 39.73 was what I was aiming at, and I've got 39.75. So, yeah, happy days. So I think that's about it for this one, guys. Just out of note, because I've got this loose bearing, I have got it sealed up in the Ziploc bag, so I'm not getting all dirt in the bearing just before anyone mentions it. Anyway, as per usual, guys, thanks for watching, thanks for subscribing, and we'll see you all very soon. Cheers now.